Got an iPhone X or iPhone 10 today with no power. Customer has already tried new battery, new charge port, new everything, to the point where they just took the whole motherboard out of the phone and sent it to me, because that's how things usually happen. So when we go to diagnose these, one of the common things that happens is that they develop a short somewhere on the motherboard. So the first place I generally check is going to be PP VDD main, which is the main power rail that comes into the phone. You're going to find this consistently throughout pretty much anything that you work on as far as phones go. And what's nice about this is we can actually find this with our multimeter. So I'm going to turn on the other camera here. I'm going to put my multimeter, actually I'm going to put it in continuity mode. So that's where when you touch the leads together, you get a beeping tone. And if I go over here and put my black probe or red probe, doesn't really matter, on one of the contacts here that we know goes to ground, we can verify that by just touching other parts of the frame. You'll hear it beep. So this is where ground is. And PP underscore VDD underscore main should not have continuity. In other words, it should not make this beeping sound if we touch it with our probe. And it is right over here, and it is actually beeping. So that is not supposed to be happening, and that would indicate we have a short, likely on that particular circuit, although it could be something else that's attached to it. Usually this is where we find them. Now, one other thing I like to do is check and see if this has affected where the battery plugs in, where we have something called PP underscore VAT underscore VCC. So again, I will put my probe here. We're still in continuity mode. I'm going to go over here to this side of the battery terminal and touch either one of these. We do not have a beep. So we are clear there. Now if we want a slightly more accurate reading, we can put our multimeter into diode mode. And in this case, we're going to actually reverse the probes. So the red probe is going to go to ground, and the black probe is going to go to where we're testing. And this is going to tell us what the value is. As you can see on the screen, we have 0.387 volts, and that is a relatively normal number for this line. And if we go over here to our VDD main, we're going to have just flat 0. So sometimes your multimeter will beep even though you don't have a complete 0 value, but in this case we do. And if we want to get even more accurate, we can put this in ohms mode. But I'm going to put black on ground, go over here to our shorted line, and you can see we have 0.4-ish ohms. Now that is going to be the same as me just touching the two probes together, because there is a certain amount of resistance in the probes. And here we have 0.3, 0.2, well, 0.1, so almost down to 1. So there's virtually no resistance here to ground, which means we have what they call a dead short. And for this phone, there's only a couple places this is likely to happen. It is highly likely this is on the inside of these two layers somewhere, or it could actually be top side of the phone underneath this shield. Although there aren't a whole lot of things here that will short, it's really kind of a coin toss. I don't generally take that shield off. It is fairly unlikely, in my experience, that the short is going to be here, although irony has a way of working against us. But what we're going to do today is separate these two layers. And to do that, I'm going to take off these little foam stickers because they like to melt when we heat up the board. We're going to have to put this on a platform, warm it up, and pull this thing apart. And as long as all of the contacts between the two layers are in good shape, we might not have to reball and replace the existing solder, because usually with this particular model that is not necessary, although there are exceptions of course, but with any luck we can save a little bit of time by not having to do that. So what I mean is we've got three different layers here we're working with. We have the bottom layer, the top layer, and then this middle piece here that they call the interposer, and all these things are connected, we'll zoom in here, by these tiny little solder joints that go around the perimeter. And we usually, I thought, had a sticker on this one, but I don't see it. If I remember correctly, I think the iPhone X has a sticker right here. Maybe not. So anyways, I'm going to take these foam pieces off. Okay, we are ready to heat and separate. Alright, so we're going to set the platform to 180 degrees. It takes a couple minutes to get up to temperature. I'm actually going to set my timer as well, and I will time-lapse the video so you don't have to sit and wait for that. But in a while we're going to see some smoke coming up here. I'll turn on the fume extractor, and at that point it doesn't take too long before we can get this thing separated. Alright, we'll get this thing cleaned up while it's warm. It's nice to get the flux off. Just makes things a lot easier. This is the best time to clean off this flux. We're not focused. There we go. When it's still hot, it makes it a little easier. It is always possible that our VDD main short is on the bottom layer, the RF board. Hopefully that's not the case. It usually isn't. So let's just confirm that we still have continuity over here. We still have a short. So now what we need to do is feed some voltage into that line to act like we're powering the phone, and see if anything gets hot. Now initially you can kind of take a look around, see if there's anything visibly damaged, or any of these capacitors that look like they're discolored, cracked, broken. Once in a while you'll find an IC, one of these big chips here, that's cracked. It's pretty rare, but it does happen. Okay, we're going to attach a wire right down here. Definitely flux. Alright, we'll set this aside somewhere I won't lose it. That's the plan. Now let's get our wire. Plenty of lead, or plenty of solder there. Let's say, which side do we want? I think that's... yeah, that's the side that goes to my probes. So we just want to attach right here. And now we should be able to see some heat. Let's see, where's a good place to use my probe though? Okay, here's what we'll do. I think we can get this on the microscope. So I'm going to take a lead from my power supply, positive. It's going to be clamped onto this wire right here. Make sure we got a good connection there, because if not, I'm not going to see anything. And then I will confirm that by touching this black probe onto ground, just to make sure we have a good connection. So we can touch basically any of these little inner pieces here. Oh, probe's coming apart. What is that about? And as you can see, it's going to pull current into that circuit, which should show us some heat somewhere. Hopefully I won't be blocking it with the camera. I'll tell you what, let's check the upper end first. And I can always move the board around a little bit, see if we're getting any heat anywhere other than where the wire is attached. Okay, I'm not seeing anything at the upper end. Nothing melted down here either, so this is lovely. I have this feeling it's going to be on the other side of the board. Like I said, it wouldn't be. Yeah, nothing. Nothing is heating up. So that's really a bummer. Unless it's over here. I'm just not seeing it. I don't know that there's any. There are a couple things up here. Yep, getting nothing on this side of the board. So, what do you know? It probably is under that shield. Oh, wait a minute. Did I just see something here? I think I did. There you go. Hidden. This guy was hidden. See that right there? I do believe that is our problem. Almost missed it. Almost went and took that shield off on the other side for nothing. There he is. Alright, that is our guy. And he is sitting right between a coil and an IC, so that's always fun. And this is something we could probably survive without. But if I have one on hand, I will probably just go ahead and replace it. Just don't want to bump anything else while I'm removing it, so that's going to be fun. We might even have a little bit of glue in here, do we? Nah, I think that's just flux. Steady hand. Whew, that's going to be tricky. I'm going to grab a hold of this first and lift. Get some lead on here. Try to, anyhow. A little much. Alright, that should be fine for installing a replacement. Meanwhile, see if our short is gone. Oh, actually, we don't need that. We just need our meter. I'm going to have to do this audibly because my camera is getting readjusted. Alright, so if we touch ground at the top, the end closest to me on this, well, the ground should be furthest. So over there, this should not. It seems like it is. What just happened here? Do we still have a short? Let's check over here. Well, I think we're going to have a short if that happens. Okay, there we go. Okay, our short is gone. I'm not sure how that happened, but that wasn't good, because that is ground. We are clear now. Let's get this off. Straighten these out a little bit. Alright, so let's try this again. We should have ground furthest from us over here, but not down here. Alright, so we're good there. Wow, that's a lot of solder. Let's get some of that off. A little sloppy. Alright, way too much flux. It's alright. Okay, we will clean this up and we should be ready for testing. So, get our bottom board here. I haven't done one of these for a while. Yeah, let's get this bottom one plugged in here. That can be tricky once you have the rest of it put together. We'll put this little piece in the middle. Top board goes up here. And now we're going to simulate the board being reinstalled, or reconnected I should say. Display is the tricky part. I'm going to rotate this here because we've got to plug into these on the bottom side, which is fun. Alright, get our battery connected, and we need something to keep it slightly elevated, so we'll do this. I hope this is a good battery. We shall find out momentarily here. So we plug in the power. And our phone comes to life. Touchscreen works, and of course we have a passcode, but that's alright. I think we are ready for reassembly. From here I'm going to warm up the surface of the bottom layer just enough so that when I put some flux on here it will melt and flow. Now there is a special flux that they make for this, and the reason for that is that you don't want a thick layer of flux, because what happens is when you heat up the board it will start to bubble, and that will prevent the board from sitting down flat. Now I'm going to use a regular flux, but I'm going to spread it out very thin. Again, you can buy a special flux made just for this purpose, but I've survived without it for this long, and like I said, I'm just going to apply it to the surface, thin it out, remove any excess, and make sure that we have a nice thin layer all the way around the perimeter. Now I don't know if you can see that, but the board does not really sit flat. It's kind of sticking up at this end. If I put it flush on the bottom, over here it's actually lifting up. So if this happens on this particular model, if it doesn't even out once we heat it up, we will clamp it down, and that's one of the reasons I do like to leave the spacers on whenever possible. Okay, so it looks like everything's aligned properly, but as you can see, I've got a bit of a gap there at the top. So what I'm going to do is let this cool down for a bit, and then we will put the top half of this platform together, and it will actually push down on the areas. Now you can weigh this down with some coins or something like that if you want to, but I prefer the clamp because it keeps everything nice and straight and held in place, and there's no guessing as to how much weight you need. So I'll be back in a minute on this one. This has cooled down quite a bit, so I'll see if we can get this on this camera. And I don't know if you can tell, but there's just a bit of a gap there at the top. So what we're going to do is set this down, clamp it into position, and now that we have it properly aligned, because if you try to put this on too early, it can shift the board on you. So you want to make sure you've got it aligned properly. We've got some solder joints that are connected, and then we're going to clean this off first because, boy, it is dusty. Alright, so we are going to take our upper half here, and this is going to put pressure evenly on the board so that everything's clamped down into position. Now remember, you can only do this if you have your spacers inside there, otherwise you just make a big mess. Solder and everything's going to run together, but those spacers are going to allow this to put enough pressure down, melt everything, and hopefully it will realign properly. So let's get this back under the scope. And I'm not going to be able to see, so we're just going to have to start a stopwatch to time this thing. Alright, this has been cooling down for quite a while, so go ahead and take it out and get a look at this thing. Hopefully it did what I wanted it to. It's going to be stuck because of the flux. So I'm just going to very carefully get underneath this thing, hopefully. Yeah, looks like it's glued down. Alright, so if we can we get that on camera? I don't think we can. But anyways, oh, there you go. So you can see the gap is gone. Everything's nice and flush around the perimeter here. So I will plug everything in again, of course, to test it, but we should have a working phone. Or a working logic board anyways.